All right, in this video I'm going to tell you all about the rate question, one of the 7 FRQ types in Calc AB and one of the 10 in Calc BC. All right, the rate question, what it's typically going to do is give you one function or maybe two functions that's modeling some sort of rate of change. Usually it's going to be a rate in, rate out kind of thing. So like maybe you're adding something, there's your rate in, you're taking away, or maybe you're processing something, so it's going away, that's your rate out of the system. These questions tend to lend themselves really well to net change theorem, so where we do an integral plus the initial value, as well as some candidates test questions. We see a lot of candidates test with the rate question. All right, so some things to remember. If you have a positive rate, that means you're increasing. Negative rate means it's decreasing. If you need to get an amount, you integrate a rate. That's your net change theorem. Don't forget to consider initial values and whether or not they should be included in your answer, because they're not always supposed to be. If you need an overall rate of change, we're going to do rate in minus rate out. Be careful on that. They usually have given you a rate. You don't need to take the derivative again. You may even need to integrate this rate of change so you can get the current amount for the whole system. Be very careful about the times as well, because quite often the rates will start at different times. So maybe, I remember in 2010, that FRQ, it was snowing like all night. And then obviously the person didn't start removing snow until like 9 a.m. or something like that. So we have to be mindful of the times that the rate in and the rate out are going. Some things to watch out for that people tend to get mixed up on: your units. If you're getting the units for a rate of change or for a derivative, what you do is the units for f over the units for x. And if you're doing an integral, you're multiplying the units instead. If you have a rate function with initial amount f of a to get an amount function, then you do net change theorem, which is going to be that initial value plus the integral. So what I'm being very specific about this one is, it's not I'm getting the amount at some time. It's to get a function at any amount I want. Note this upper bound, right? So this says starting here, there's your initial value. This is where the system starts, up to some time t. That's how I'm going to get an actual function. That's how I get actually a of t is what I usually call it, capital A of t for an amount. So be very careful about that. But we should be hopefully pretty good at that by now. Guess it doesn't want to let me use my eraser. It's fine. All right, so now we're just going to get right into an FRQ. This is the 2017 Calc AB rate question. When a certain grocery store opens, it has 50 pounds of bananas on a display table, and customers remove bananas from the display table at a rate modeled by f of t. F of t is measured in pounds per hour, and t is the number of hours after the store opened. After the store has been open for 3 hours, store employees add bananas to the display table at a rate modeled by g of t, where g of t is measured in pounds per hour, and t is the number of hours after the store opened. So the first thing I'm going to do, I haven't even read a question. I'm going to go through, I'm going to mark up this FRQ. What I see first, in the very first line, they say 50 pounds of bananas. That seems important. That seems like that's going to be my initial value. I'm going to just label it IV. Okay, then f of t, that's customers remove at f of t, right? So that means the customers are taking bananas away from the system. That's going to be my rate out. Units are always important. F of t is measured in pounds per hour. T is the number of hours after the store opened. Then in the next line, we see that the store employees are adding bananas. G of t, that means this is my rate in to the system. And here are the units. They're the same as f of t. Okay, now I'm going to actually look at the first question. Now, I want to point out that these annotations that I just made, they're going to go away as I move on to the next question, but obviously when you do these annotations, they'll stay there for your whole time. How many pounds of bananas are removed from the display table during the first 2 hours the store is open? So I want to know how many pounds of bananas. So I want an amount, I want a number of bananas. So that means I'm going to do an integral. So I have a rate function. To go from a rate to an amount, I do an integral. It says during the first 2 hours, so that's concluded that my bounds are going to be 0 to 2, and I'm integrating f of t. Now I know some people might be thinking, well, why aren't you talking about the 50 pounds of bananas it started with? Well, it just wants to know how many are removed. It doesn't want to know how many bananas there are, just how many were taken away. If I wanted to include the initial value, that would mean that the question was asking about how many pounds of bananas are there entirely. So I'm going to do that. This is a calculator question, so at this point you would go into your calculator and you would get 20.051. So that's the number of pounds of bananas removed during the first 2 hours. When what I wrote would give you full credit. F of t is labeled in the setup of the problem, so you can just put f of t. Now, if you like to write out the function, by all means, write out the function. But this is all you have to do. Okay. Part B, find f prime of 7. Using correct units, explain the meaning of f prime of 7 in the context of the problem. So this is beautiful. They tell you exactly what to do. They literally say, find f prime of 7. And this is a calculator question. You don't need to sit there and do the product rule and the messy chain rule or anything like that. You just go to the calculator and say, hey, calculator, what's the derivative when t equals 7? So when you do that, the thing will let me zoom in, we find that f prime of 7 is equal to negative 8.120. Now the next part of this says using correct units, explain the meaning of f prime of 7 in the context of the problem. So what I'm going to do first is find the units, and I want you guys to be careful. I don't want you to think once I've found the units, I've explained the meaning, because that's not true. Units don't tell you what's going on, they're just units. So remember a couple slides ago we said to get the units for f prime, what we're going to do is we're going to go the units for f of x, for us that's pounds per hour, over the units for x, which is hour. Now I'm saying x a little liberally. Obviously we're talking about t, but I think you get the point. So this derivative is talking about pounds per hour per hour. Now I'm going to give you a little bit of a boilerplate sentence, like basically a Mad Lib for explaining something. Anytime you need to explain the meaning of the derivative, basically it's this. The fill in the blank. For us it's going to be what f of t is changing at f prime of 7 units when, I'm a little off the screen, I'll move it in just a second. So when we're explaining our derivative, we need to be very careful. We need to talk about the original function itself. Oh my goodness, just go on the screen. We need to actually talk about what the function is, because the derivative is talking about how the function is changing. So we need to say what the function itself is. Is changing at. The reason I say is changing at is because sometimes it can be a little tricky how we word it. For example, our derivative is negative. That means that the system that something's decreasing, right? But if you say decreasing and then you say at a negative value, then it's kind of like double negatives and make it positive. So that's why I always just say is changing. And we do also need to make sure that we include what time this is happening at, right? So we know that it's at t equals 7 hours, so we would need to include that. So now let's go actually fill in the blank. F of t is the rate at which customers remove bananas. I'm going to write in 2 spots because I ran out of room. So the rate at which customers remove bananas is changing at f prime of 7. We just found that negative 8.120. And we know the units are pounds per hour. So then the whole explanation would be the rate at which customers remove bananas is changing at negative 8.120 pounds per hour when t equals 7 hours. So that's our full explanation using correct units. So just make sure that when you're talking about derivatives, you're talking about how something is changing, include the number with the unit, and what time you're talking about. All right, next one. Is the number of pounds of bananas on the display table increasing or decreasing at time t equals 5? Give a reason for your answer. So I want to know if the whole system's rate of change is increasing or decreasing. Well, to get the rate of change for the whole system, that's just the rate in minus the rate out. Remember, this was the rate out. This is the rate in. So what I need to do is I need to find g of 5 and subtract it from f of 5, and subtract from it f of 5. When you do that, remember going into the calculator, you're going to end up getting negative 2.263. So now based on that, I know that this system is decreasing. The number of pounds of bananas on the display table is decreasing. So what I'm going to do is I'm going to say decreasing because g of 5 minus f of 5 is less than 0. Now, if you want to say is negative, that's fine too. I saw myself running out of room, so I put less than 0, but negative is what we're really talking about. Okay, we've got one more part left, and we want to know how many pounds of bananas are actually on the display table at time t equals 8. So I need to consider the initial value, right? So I know I've got rates. I'm going to have to do integrals to get that amount. So let's start with how many bananas there are originally, which was 50. Now, I know that bananas are being added. So I'm going to integrate the rate function at which they're being added, which is g of t. Now what I have to be careful about, this is one of those things that I was mentioning, they don't start adding bananas until t equals 3. So I'm going to go 3 to 8. And bananas are being removed as well, so I need to subtract the integral of f. That one actually does start at 0 because people start taking bananas as soon as the store is open. So that one's going to be 0 to 8. And when you go into your calculator for this one, you get 23.347. That would be our answer. So something I want to point out, this was a calculator question. So yes, there was a lot of stuff that we just did in the calculator. But you notice that I also wrote down the things that I was doing. Whatever happened in the calculator, I also wrote down what was going on. So that way they didn't think I just pulled a number out of thin air. Writing these integrals and including the initial values show the AP grader that you know what you're talking about. So let's just take a quick glance at the scoring guideline. Part A, remember we were wanting to know how many pounds of bananas are being removed. So we do an integral and we give the answer. Right over here, 2 points. 1 point for doing the integral. Like I said, you have to tell them what you're doing in your calculator. 1 point for the answer. Part B, that was the one where we had to find f prime of 7 and explain it in the context of the problem. We got 1 point for the value, 1 point for the meaning. Part C, we wanted to know, is the number of pounds of bananas decreasing or increasing? Well, we got a point for considering f of 5 and g of 5. Remember, we found that rate of change being rate in minus rate out. And then once we had the number, we actually answered the question, saying it was decreasing. And we explained why. The last thing was we wanted to know how many pounds of bananas are on the table at t equals 8 hours. So we did 50 plus some integrals. We got 2 points for integrals this time. Now imagine that's 1 point for this guy and 1 point for this guy. Because remember, it was very important, one, that f was a negative integral because we were removing, g was a positive integral. The bounds on g were not the same as the bounds on f, so they gave a lot of points for the integrals on this one, and you got 1 point for your overall answer, which would include considering the initial value. Okay, this video didn't have any candidates test in it, but hopefully we can get some candidates test out of some extrema knowledge, and we'll get a net change theorem video, so we'll see a little bit more of that. Okay, have fun.